Hey everybody, welcome back. Happy December. We're at the end of 2020. Yes, we're really close enough that we can see the end, the light at the end of the tunnel, and I don't think it's a train this time. Hopefully. Woohoo! We're going to have one more TLC conversation, I think, in December, but it may end up being January. We're having some scheduling issues, so I'll tell you more about that as soon as I have the information. As always, join the conversation over on the TLC calls channel on the TLC Slack, or you can use the Zoom chat if you need to. Today, we're going to be talking with Chad Sanderson. Welcome back, Chad. Really happy to have you here. He's going to talk to us about advanced product experimentation, basically testing anything anywhere. So quick intro, not that he needs to be introduced. We all know him well, but I changed your title, and I am aware that your title is not 2 times junior Olympian, but I would like you really quickly to tell us a little bit about your 2 times junior Olympian ship.
Sure. So even though I may seem like a geek now, my dad used to be a relatively famous cross-country coach. He was the coach of the first ever blind national champion. He was on CNN and a few other things. So
Awesome.
I grew up in in a pretty extremely athletic household. And I started doing Taekwondo competitively when I was about 8. And yeah, there was a time when it wasn't inconceivable that I was going to do that sport professionally. I did go to the Junior Olympics twice, and I won one of those times. And I probably went to over 1,000 sort of competitions over like a 8-9 year period, something like that. So I've grown out of it. I'm a lover, not a fighter anymore. And now I do this stuff. So
now we fight for numbers and data.
yes.
Yeah. And we love the data. So anyway, thank you. Because I know we talked about it once, standing in line to turn in our drink tickets at CXL, but I couldn't remember the sport. So thank you for sharing. So welcome back. I'm going to give you the screen share because I know you have some slides to share for us. And again, folks, mute your lines unless you're asking or answering questions. And feel free to put questions in the TLC calls channel in the TLC Slack. All right, let me stop share and I will pass the share to you, sir.
Okay. This here. All right. And can everyone see my screen?
Yes, sir.
Yes. Okay, cool. So thank you for that introduction, Kelly. I'm pretty excited to talk to you guys this morning. My background is a little interesting, even within sort of the realm of analysis and CRO, because I started off more as a marketing analyst. That's kind of where my career in this space began. The work that I did with Subway and also subsequently with Sephora was mainly on the marketing heavy CRO side of the world. That's pretty much all I really knew about. And I tried to optimize pretty highly for that space. So about 2.5 years ago now, I moved out to California. And then Ronnie Kohavi, who used to run the Experimentation Platform team at Microsoft, sort of like the grandfather of A/B testing. He helped start the platform and the program over at Amazon as well. And that sort of kicked off what we know as this A/B testing revolution. Essentially asked me to come to Microsoft and do work with him. So that's what I did. And for the first time while I was there, I worked on an internal platform at a really big technology company and saw some super interesting problems. But I realized relatively quickly that that's actually what I wanted to do, is solve these large experimentation problems that really had not been solved yet, and create engineering solutions to deal with them. After that, I left and I went to Convoy. Convoy is a startup. I'll talk about them in just a second, but I am essentially running a few teams at Convoy right now. Our data engineering team, our machine learning platform team, our analysis and reporting / visualization team, and a few other things. And then also I manage our internal experimentation platform. But of course, I would say that's the piece that's closest to my heart, and it's the one that I selfishly love the most. So don't tell anybody else on that team. But I would like to share a little bit of how my priorities have changed. What are some of the major new problems that we have to work on at scale, and sort of how I think about solving some of those really big experimentation problems, both from an engineering perspective and then also from a cultural perspective, that may be helpful to people when making your own decisions in this space. Okay. So a little bit about Convoy to start off with. Convoy was founded in 2015. They are what's called a digital freight broker. And if you're not super familiar with the world of freight, basically you have a shipper. So that is some company that is looking to transport goods from one location to another location. And they work directly with a broker, and a broker maintains an extremely large network of truckers. We actually call them carriers, because carriers, it's actually a B2B business, where you might own 10 or 11 or 12 or 500 trucks. And the broker is the one who coordinates those trucks with the shipper to make sure that they arrive at the facility to pick up those goods on time. And then they also arrive at their destination facility to drop them off. And there's a lot of complexity along the way, but generally speaking, up until about 2018, this was an extremely manual, very legacy industry, where the incumbents in the brokerage space were doing a lot of the work by hand. The only way to scale your operations was really to hire more human beings. And Convoy's perspective is that a lot of the work that humans are doing today can either be replaced with technology and machine learning, or the machine learning and the technology can significantly augment what a human is doing and make them radically more efficient. So we had a $400 million Series D last year in November of 2019, right about this time, actually. The company is right about at 1,000 employees. And on the, technically it's still B2B, but it's closer to the B2C side of our marketplace is our carrier marketplace, which has about 50,000 active customers. The number of shippers that we work with is much smaller than that. So the sample size is very small compared to when I was at Microsoft, and we had, you know, tens to hundreds of millions of visitors every single month. Our founders come from Amazon, and they bring a lot of that deep experimentation culture to the business. So experimentation is something that if every team is not doing, it's certainly something that they are aware of and are actively pressured to do by leadership. I don't think I need to tell anybody why we should experiment. Obviously, I'm preaching to the choir, but I did want to, I think this is it's good to go over the definition to sort of see what experimentation is not. For me, and I think for most people in the scientific community, it's a great way of measuring the causal evidence using the scientific method of some particular point in time in the past. And that's actually really different from the ways that a lot of teams are using experimentation. Even within Convoy, a lot of teams are not using experimentation this way. It's used almost like a forecast of what's going to happen a month from now, or 6 months from now, or a year from now. That's actually not correct. And I'm going to talk about that and some solutions for that we've come up with a little bit later. So in terms of why we have our own internal experimentation platform, the larger case for platforms in general, as I'm sure pretty much everybody knows, is that doing science at scale is really hard. There's a lot of engineering complexity that comes along with being able to deploy experiments. So if you're using a third-party service like an Optimizely or an Adobe Target, they're abstracting a lot of that complexity away, so the customer doesn't have to deal with it. They can just focus on building out the experience. But in our cases, especially in other cases, especially at Convoy, where the environment itself is radically more complex than what you see in most businesses, or at least I'll say it may not be radically more complex, but we've realized that it's complex enough that a third-party platform can be very limiting, actually. And that's why we needed to invest in a platform that can do a lot of things that a third-party tool actually cannot do. And again, I will talk about that soon. So this is going to be a quick introduction to what our tool is and how it actually works and what it does. This is just sort of our default experiment page where we show all the experiments in a list. It's pretty basic. So there's a few core components of what our experimentation platform does. A lot of these have overlap with existing tools that are out there. One of I think the place to start is in assignment, just to like quickly understand what assignment is. And again, this is all, if you have a third-party tool like Target or something, this is something that's all like happening in the background. More than likely, your engineers or your data scientists or analysts don't have to think about it so much. But assignment is basically the process of determining whether or not an entity in your experiment is going to receive the control or treatment. You can't actually do this in a naive, like flip a coin and we're just going to assign it one way or the other. Because once you start thinking about rolling experiments out, going from 1% to 5%, then to 10%, then you need to have some way of maintaining consistency as you go up and down. So just reconsidering every single user when you flip the coin actually doesn't work. And there's some interesting things that you could do there. That it's actually a pretty standard process. All platforms do this. The thing that a lot of the platforms don't do that we really need is this concept of stratification. So like I mentioned, Convoy is a smaller business. We're actually a two-sided marketplace, meaning that if there's a change to our experience that happens to one side of that marketplace, whether it's a change to what our shippers see and how they interact with our app, or if it's a change to what our truckers see and they interact with our app, those things could actually impact each other and therefore bias our experiments. So we have to be really careful on how we're actually randomizing and what we're randomizing on. So in many cases, it's actually not fine to just randomize on a user. That's too basic and it can lead to some what we call interference bias. Something that we can randomize on instead is a measure of geography, like self-contained geography. Uber and Lyft basically have the exact same strategy. So very frequently they experiment on distinct metros that their drivers and their riders are in. And there's some scientific reasons for why that is that I'm not going to get into now. But Convoy basically has that exact same problem, except even more so. At Convoy, in the freight world, you have a concept of a lane. And a lane is basically a distance between 2 points on a map. So Seattle, where I live, to San Francisco would be a lane. And then you have many shipments within that lane. And so to not run into this problem of interference bias, it's really common for us to do randomization on the lane instead of the individual shipment whenever we're rolling out new features. Like let's say we're making a modification to our pricing algorithm. And that is, doing that randomization is not super straightforward. We have some lanes that are just very, very densely packed with thousands of shipments going through them every single week. And we have other lanes, like let's say, Montana to Colorado, there's just not a lot of outbound freight either way. And it's very, very sparse. So if we randomize and just happen to get unlucky and put one or 2 or 3 really big lanes into control or treatment, then the entire experiment is going to be extremely, extremely biased. So stratification gives us this ability to sort of define groups and clusters of lanes, and then we split across those evenly. So it's like a randomization strategy that's one order above what most people use, I think. We also have the ability to do SQL targeting and filtering. So because our platform is really tightly integrated with our data warehouse, it means that we don't just have like internet clickstream events to filter on or to do segmentation on. We have all the data at our disposal in the data warehouse. So a data scientist could very easily like just write a simple SQL query, like I just want this experiment to be run for people on the platform that joined within the last 5 minutes. And we can have data that's streaming in virtually real time that sort of runs that query and checks that before the experiment runs. Before I move on, the other thing I wanted to talk about like really quickly was this idea of a metrics repo. Metrics is something that when I was at Subway, we struggled with a lot because sort of Adobe Target had their definition of revenue, and then the business had their definition of revenue. And it was very rare that those things actually matched up correctly. One of the values of building our own platform is that we can guarantee that the revenue metrics that we use and the revenue metrics that the finance team is looking at are the exact same. And there's a pretty huge amount of value to that. So in terms of where our team is high level, we run about 30 plus experiments per month on average. On average, it's around 30. And sometimes in the year, it'll be higher. Sometimes it'll be lower. We have 15 pods. So these are basically groups of engineers, product managers, and data scientists tackling different problem spaces and that are actively running experiments at any point in time. I know this may not sound like a lot for a company that's making this big of an investment into experimentation, but we have very, very low traffic relative to the Microsofts and the Googles and Bings of the world. So 30 plus experiments per month on the amount of traffic we have is actually quite good. And a lot of our business units are totally brand new, and they will be running experiments very soon as well. So this is a quick chart of how experimentation has actually grown at the company. The plot you see on the left is 2019. Each of the little brightly colored circles at the top is a different team that was doing experiments month to month. And the plot on the right is where we are today. As you can see, there's been a lot of growth, and both in the volume and the amount of teams that are doing experimentation. So building a platform that sort of unlocked a lot of the capabilities that teams couldn't get on their own was quite nice from a volume and measurement perspective. Okay, so now that that's out of the way, I do want to talk about some actual experiments and how we think about doing different types of experiments. At Convoy, because we're a backend system, we sit on top of our data warehouse, we can look at any metric, and we can also randomize on anything. So we could randomize on not just the user, but a shipment or a lane, or it even could be something that's totally offline, quote unquote, like an email or an ops manager or something else. All an engineer has to do is pass us some ID and some key, and we'll randomize on it and not really care what it is. That opens up a lot of opportunity in terms of where we can experiment. A good example is our pricing models. So Convoy doesn't actually have one pricing model. We have many pricing models that sort of roll up to one pricing model that eventually makes a decision. And those many pricing models are all doing slightly different things, like they're all computing a different piece of the puzzle using slightly different data. And there are teams who own those different components. One thing that those teams do is a process called backtesting. And essentially what that means is that you're running your model offline, you're training it, and then you're comparing those predictive results to whatever you have in that's serving in production at the time to see if it's better. And this is something our teams do all the time. But when your models are so tightly coupled, when it's this very componentized process and one model depends on another model, then it's actually really important to understand in production, if I were to push this, not only do I have good results on like my piece of the pricing world, but that it's interacting and playing with all the other models like very nicely. And it's the final result it's producing is good. And this is one of the ways that we use A/B testing very, very frequently, because sometimes weird stuff happens and you need to be able to check that and very accurately identify what the source of the problem is And there's really no tool better than that, than experimentation. Another example is location data. This is definitely not something I thought about when I was a marketer, but because we're a freight brokerage, we have a metric called on-time delivery. And that metric, we can use it as a sales tool and basically go to our partners who are shippers and say, hey, listen, 95% of our freight is on time. That means that we're a great partner. And because we can prove that through our data, then hopefully we can win more of your shipments. You can pay us money for us to deliver your loads for you. Even though we're a very, very new company in the market, we use those types of metrics as like a seal of approval. So making sure that we're always improving metrics like on-time delivery are really important to particular teams. The location team thinks about this a lot. We have concepts called geo-fencing, which basically means once you arrive in some area, we're able to automatically detect through the app like where you are. And this will make more sense in just a second because I'll give you a real example. And then finally, we have what I think a lot of you are already familiar with, which is the user experience. So if you have an application, if you have a website and you're adding new features or you're changing the flow or you're changing copy or something like that, these are obviously things that we run a ton of experiments on as well. So here's a quick example of a geo-fencing experiment. At one point in time, the way that we built our geofences was only through this like radius-based model. You can see an example of that at the top right. It's like a big circle, right? But there was a problem with this. So the way that we were actually using these geofences is in freight, there's a concept called detention. And that means that if a trucker is where they're supposed to be on time, and that facility is not ready to unload the goods that they're carrying, then the broker is actually responsible for paying them what amounts to an overtime fee the longer that they wait. So we need to know with a really high level of accuracy, both for our on-time delivery metrics to make sure that people are actually where they're supposed to be when they say they are, and then also that when this whole concept of detention comes around, we are paying out the accurate amount and not a severely inflated amount. And you can kind of see a problem here, how the actual, I don't know if you can see my mouse, but if the actual radius for the geofence is crossing the highway, theoretically, somebody could pass through that geofence. They could be counted as on time based on some logic that we have. They may start accruing detention, and it could take them another 45 minutes or an hour before they actually get to the facility. If you have a bad actor, you might have someone who just passes through this point on the map and just keeps going just so that they can accrue a huge amount of detention before they actually deliver the load on time. Things like this have happened in the past. So what the geofence team decided to do was move away from this sort of like generic blob model where we just dump a circle wherever the location of the delivering facility is, and instead focus on building out polygons that were much more accurate. But this actually is not something that we can just do in a programmatic way and roll it out to 100%. One of the dangers of doing that is there might be situations where whatever service that we built to make this happen drops some geofences by accident. And we can't even drop one geofence. We need to know really, really explicitly that all of them are being covered, or at the very least, if it does drop geofences, we need to understand that so we can figure out what's wrong with with this service that's making that happen. The other thing that obviously we want to measure with an experiment is, was there truly an impact to metrics like on-time delivery? Do we see those change in any sort of meaningful way? Are we paying less attention? That type of stuff. Here's an experiment that happened in the app. So this was the facility ratings experiment. This was brand new functionality that we added. So if you're a trucker using our trucker app, you can basically open it and you're in an auction. You can bid on a shipment, and generally speaking, the lowest bid wins. And that's what Convoy is paying the trucker to basically take that load. It is a lot more complex than that because there's a whole bunch of like model and intelligent logic that's going on and when we actually accept the shipment or not. But one of the features that we added was this ability to rate facilities. So I just showed you an example of a facility, and there are some facilities that are amazing. They're really well run. They're easy to get into and out of. You don't have to wait for a long time. You don't need to accrue very much detention. They unload the stuff in a super professional way. There are some facilities that are absolutely horrible. There are times where it's really difficult to even get your truck into the place where you can unload your stuff. There's times where they make you wait, even though they're there. Maybe the number of actual like cargo holds where the trucks will pull into to unload, there's not very many of them. So you just end up waiting for a long period of time. And oftentimes truckers will not know this information before they actually start a load. So this experiment was to add a brand new feature that would allow a trucker to rate a facility. And with the hypothesis being that if truckers got some type of confirmation that a facility that they were delivering to was ranked as good, essentially social proof, that they would be more inclined to actually bid on that shipment and eventually take it. And that is, in fact, what happened. We saw a 7% increase in bids for facilities that were rated good, which was like, I believe, above 4 stars or something like that. There was a 10% increase in the shipment accepts. So that means not just making a bid, but basically you've said you have won this, you have like the best bid. Do you accept it to actually take the load? That went up significantly. And then we didn't actually see a decrease in accepts at poorly rated facilities. Something I wanted to mention really quickly on this slide is that a lot of you sort of may have heard the advice before from potentially companies that I worked at in the past that you should focus on incremental changes. Because if you make a large change, a large sweeping change like this with a lot of different components, it's really hard to know what part of the feature resulted, like what part is actually accounting for this increase. And so some people might see stuff like this and wonder, well, okay, this seems like a lot of stuff to test all at once. How can you be sure what caused the change? And my general response to that is when the amount of, that is an affordance that you have if you have massive amounts of traffic, right? If you have millions and millions of people who are coming to your website, then you can afford to actually test incrementally and know very clearly what affected things because you're able to see impacts, of like less than 1%. And those less than 1% impacts were likely highly statistically significant. They would be, you could detect a change of way less than 0.5% at a place like Facebook or Google or Microsoft. But if you're a company like us and you actually don't have much traffic, we can't afford to do that. We have to make changes that are, going to result in 5%, 6%, 10%, 20% improvements. And those are just big swings. We could be right about them and we could be wrong about them, but generally it's like some meaningful and significant alteration to the customer experience. So this is like part of my job is helping teams think about these experiments. But another big part of my job is actually looking at the state of experimentation at the business and then building products and functionality to make that better. One of the questions that we asked, so this is like one survey question, is we asked our data scientists, how many hours does your experimentation workflow take? All these different areas. And you don't need to read exactly what those areas are because that's not really the point. The point is that there are many different surfaces in which somebody might interact to do an experiment. And there's really no one silver bullet that you can attack here that's going to have an absolutely profound impact on something like efficiency. Even the things that take the most time, the 4-hour buckets there, sort of in the middle and then at the end, those are the things that are probably the hardest to automate. One of them is just critical thinking about the results. And then the other one is the actual process of like building out a report and communicating results and presenting and things like that. So these are the types of problems that I think about. How can we improve this? And this is actually a very relevant problem for us to think about because it takes around one data science week of effort to analyze every experiment. There are some experiments on certain teams that are way longer than that. It takes up to 3 weeks just to do the analysis. In some cases, it can take longer than the time to actually run the experiment. And there's a lot of reasons for that. The big reason is that, again, we have a very small amount of traffic. So the amount of statistical effort that we have to put into analyzing these tests is not small. We use a lot of statistical methods that most companies probably don't use because we're trying to get at different cuts of the data in a relatively high power way. And part of my job is to say, we have a bottleneck on efficiency. How can we potentially solve that through product? There's other problems that we have as well. I've already been talking about small data and very complex experiments. One of the, excuse me, one of the problems with very complex experiments is that they're not as reproducible. They can happen in a vacuum. Data scientists can decide on some interesting method that they want to try, or an analyst may come up with an interesting method, and that just sort of gets like lost to the void of time, and nobody else in the company is able to use it. And if you have certain business units within the company that have a lot of statistical horsepower, then you'll see a lot of like really great stuff happening over there. And oftentimes it doesn't translate to the teams that don't have that statistical horsepower. Marketing is often one of those teams. They usually have very few data scientists, if any at all. Deep segmentation is also something our customers care about. It's not actually enough to just look at these overall aggregates. They have to dive deep into the data. And look, we have many, many, many different segments that we care about. And that is a really time-consuming process. That also obviously has an impact on power when you're looking at like many different independent cuts of the same data. So that's problematic. And then our market conditions radically change over time. So the freight industry is not stable. It is massively, massively volatile. Truck prices could be at an all-time high in January. They could be at an all-time low in March. And so when your market is changing that much, it's really hard for our finance team to separate out what are the impacts of experimentation on our business, what are the impacts of our product team, what are the impacts of our marketing teams. These are really big challenges, and making wide sweeping claims like we are going to make $1 million this year based on the projected impact of our experiment is a really good way to get yourself in big trouble at our business. There's also a lack of centralization. So just reporting isn't particularly transparent. If you want to know what happens in an experiment, how did it go? How do I use that to make decisions about my life moving forward? That can be pretty hard to do. And there's also a lot of time-intensive follow-up questions. So if you're a product manager or a marketer and you see an experiment is run and maybe the result isn't what you expected, you really want to understand why it is that way. That way you can iterate over it and you can work with your designer to build something better. But these types of questions do take time, especially if it's not something that the data scientist thought about answering in advance. It requires people like building queries, and there's a non-zero cost for that. And then reporting is also a pretty time-consuming process as well. But there's a lot of really cool things that is, I won't say completely unique about Convoy, but it's just cool stuff, I guess. The first one is we have very small data. So our data is very complex, but it's also very small. And when your data is very small, it means that you don't have to worry about cost. You don't have to worry about computational cost. When I was at Microsoft, as an example, the entire experimentation platform that we had was fundamentally built around cost optimization, because teams like Bing were processing, terabytes of data, and there is an enormous cost to that when you're doing all these joins in order to make metrics and all these other different types of things. We don't have to worry about that at all. So we can essentially focus exclusively on some of these like really challenging analysis problems. We also have a pretty small surface area. The data platform team, which is my team at Convoy, was around 6 months before I joined. That team now owns basically our entire data stack end to end for the entire company. And it's really easy for us to get in early if a team needs experimentation to insert ourselves and say, hey, you should probably be using our tool. And if you can't use it for this use case, then we can build something that can help you. And there's a lot of good reasons for that maybe I could talk about later when we're thinking of what's sort of the far-reaching future. And then we only have one source of truth, so that's cool. So here's some solutions, some product-based solutions to things that we've built out, just to give you an idea of what we've focused on. This is a concept. This is something called a rollout that's within our tool. It's essentially an automated experiment workflow. The problem here was that data scientists and engineers were spending a lot of time doing monitoring, figuring out if anything was breaking, deciding to roll things up, then rolling them back. Once the experiment had actually reached a point, a period of time where it had run long enough, a lot of people just weren't remembering to come back and check the results of the experiment. They'd let it run for 8 weeks or 9 weeks instead of having an explicit cutoff date. And sometimes you would want to actually gradually roll out your experiment to different rings of users. So you may want to start by rolling it out to an internal population that can do QA on it. Then you want to start by rolling it out to the entire organization so that they can play around with it. Then maybe you want to roll it out to a smaller subset of very friendly beta testers. And then you want to start dialing it up to 1%, 5%, 10%, and so on and so forth. And this is a tool that we've built that makes it really, really easy. You don't need any coding experience to be able to do that. Anybody could do it. I could do it, and I'm not a developer. So this is sort of like trying to tackle that efficiency issue that I mentioned before. Metrics at Convoy are also very, very important. In fact, my perspective is you will never get to become a culture of experimentation if your leadership does not really strongly, deeply care about metrics and ask a lot of questions about them. We have WBRs, which are weekly business reviews, meaning our leadership will sit down in a big meeting and have a presentation, and that presentation pulls in data automatically from our data warehouse, and it updates it every week, so it keeps people transparent. And so this whole concept of being able to really clearly separate fact from fiction from a data perspective, we have a really volatile business, like I said. How do we actually know the impact that we're making is a really good entryway point to do a lot of A/B tests. However, what that means is, number one, our metrics actually have to be very good and very comprehensive and very useful. It has to be very easy to add metrics. And there has to be a very easy way to actually turn those metrics into some type of statistical output, given all the complexity that our business has. So there's a few things that we've built for this. We do have a metrics repo. I could tell you a little bit about how it works if you're interested, but I'm just going to give you the high level concept for now. Basically, a data scientist can write a metric in SQL. This is something that exists in the data warehouse. We will automatically populate it through our front end. And then in order to actually generate those metrics in an experiment, you're just clicking a button. So it's probably very similar to like your Adobe targets, except this is not just for clickstream metrics. This is for every single metric that could conceivably exist in your company. We do the same thing for dimensions and segments. Pretty straightforward. You just define them, and then you can go through and sort of select them for an experiment. And this gives you the ability to slice and dice all of your metrics by all the dimensions that you choose. We have another concept called metric sets and dimension sets that are basically just collections of metrics that people use frequently. So if you have 100 metrics and 100 dimensions, all you have to do is select those two for the experiment, and we'll do sort of all the slice and dicing on the back end. And then we also have a concept called an algorithm repository. The only screenshot I had of this was like a very early sort of iteration, but we actually have a lot of algorithms now. And basically what you can do is once you select a metric and once you select a dimension, you can select an algorithm that you want to use. And these range from different types of t-tests. So like one-sided t-test to two-sided t-tests to like different types of regressions, the double ML models. We have diff and diff designs as well, and we're moving into quasi-experimental models relatively soon. And test drive will handle all the computation for this on the back end. The final thing I'm going to talk about from a feature perspective that we have today is this idea of predictive metrics. And a predictive metric is essentially a algorithmically driven metric. This is basically what it requires is a set of input, like short-term input metrics that are really hard to connect to revenue. So it could be impressions, it could be the number of clicks on something, it could be more UX-centered metrics. And then you also select a set of output metrics like revenue or buying power or basis points or something like that. And then this algorithm will actually run to produce a reasonable prediction of what the future is probably going to look like on a revenue metric 6 months down the road. So this is actually not something that we encourage, like random people to use. It's something really a data scientist should use. There's a pretty clear user manual for it, but we try to drive people towards creating predictive metrics instead of running experiments and then using a non-predictive value to make a prediction. And here's our dashboard. This is where it all appears. That's cool. But there's one other thing that I wanted to talk about relatively quickly. I know I'm sort of on the verge of running out of time, but that's like one side of experimentation for us. Convoy actually has around 400 ops and brokerage personnel. These are people that are on phones, they're talking to shippers, they're talking to other customers and making sure that their experience is great. We have an account management team. We have a really big sales team because we're a B2B business. And the way that your sort of average brokerage works is that the role of the broker is to have a really, really deep relationship, both with the customer and then it's actually your account manager that has a deep relationship with the shipper. And their job is to handle like unusual stuff. So when a shipper says, hey, I really need to change the appointment window for this particular shipment from 1 to 2 p.m. on Sunday to 5 to 6 p.m. on Monday, and I'm doing that 8 hours before the shipment actually gets there. It's up to the broker to actually navigate all of the crazy things that go along with that type of request. And that's on both sides. So maybe a trucker, gets into an accident on their way to pick up the shipment and breaks his leg. That sort of communication to understand what happened, what do we do, go back to the shipper and make sure that they understand the scenario and what we're going to do to mitigate is really important. And it will never be possible to automate this job entirely. There's just too many moving parts. And in fact, there's a lot of different sort of human in the loop aspects of Convoy, and pretty much all businesses. Operations is one of them. We also have a partnerships team and a finance team and a logistics team and a sales team. And something that I've observed in my career is that very frequently, these teams are making decisions that are fundamentally radically more impactful than the product choices. Product teams might be adding a new feature every now and then, whereas a sales team is deciding we're going to fundamentally change the type of customer we're going after. And the whole purpose of experimentation is to quantify our risk and provide a surface for measurement so that we know we're making the right decisions in an iterative way. And we do a really good job of doing that on the internet or on our application. We do a terrible job of actually doing it in the places where, in my opinion, it really matters the most for the business. So this is where quasi-experiments come into play. There's a lot of different types of quasi-experiments. These are run by like doctors and people sort of working in the social sciences field or the economics field that are trying to understand the impacts of like policies and laws as they're rolled out across countries. They're essentially time-based, and there's a lot of really smart intelligent things that you can do. I've listed a couple examples here. A regression discontinuity design above, which basically statistically looks at the pre-post, and then something called a synthetic control at the bottom, where you're essentially modeling out what you think the control would be, sort of given the nature of the business before you actually made your change, and then you're doing an A/B test between your treatment and your fake control. And there's a lot of use cases for stuff like this. Operational strategy, sales strategy, making changes to space. Convoy has a really big investment in tooling for our operations team so that they can be hyper efficient. And we can't really do an A/B test there because there are standard operating procedures. And if an operations manager who's sitting right next to another person has a totally different experience, that's just going to result in some pretty bad outcomes. There's a lot of other big changes. Clearly, I was supposed to lead in here with something about big changes, but there's a lot of other big changes that you could use to test this. Many of these features are things that Convoy rolls out, not really as experiments, but just as huge new surfaces and revenue generating mechanisms. And these are great places for a quasi-experimental design. And the reason I'm sort of saying this is a current and ongoing very large investment for our team. And I believe that might be the next slide here. Yeah. So what's really important to do is to define the core problems that your business actually has. Convoy's really big problems are offline. It's how we work with our shippers. It's how we negotiate deals. It's the type of sales strategy that we have. Yes, we absolutely want to optimize for our application, but if we just focus on that, we're really radically underserving the business and not providing really good measurement and quantification of risk everywhere else that is important. And so the perspective that I took going into Convoy was really trying to understand what are all the things the business wanted to do, what are all the things they wanted to measure, what are the major problems that we have? We have small data, but that can be a good thing. We have a lot of complexity, and that series of problems is what determines the solution that we either build or we buy. There's not ever a generic sort of one size fits all problem. And one of the reasons I like giving this presentation is because I think a lot of people who are responsible for CRO or experimentation do have this approach of, I like this optimization tool because of the features it has, and not necessarily how well does this tool actually solve the problem for my company. So the future of where we're potentially going, automated analysis. So this is doing like a lot of like fancy statistical stuff, offline experimentation, which I mentioned, doing holdout groups and all up reporting across the entire business. And maybe at some point in the near future, open sourcing this so it's available to the world. And that's it. That's my presentation. It's been great talking to you.
Awesome. Let's open it up to questions. We got about 10 minutes. I know Guido asked for a GitHub link, but I think you just answered that as far as maybe someday in the future open sourcing to the world. Does anyone else have questions you want to ask? Okay, Dylan wants to know, how big is the team that built the tool?
Excluding me, 4 people.
So 5 total?
Yeah, five total. I don't really count though, because I work across a lot of different services. It's like 4.25, I guess you could say.
And Chad, what was your team composed of and how long did it take?
So our team is all engineers with the exception of myself. The experimentation platform actually started, as it very often does, as a offshoot of one of the pods that really needed it the most. So it was kind of like a little janky tool. They started that in 2019. It became its own official team in around October of 2019. So we've existed for a little over a year at this point. And also all the progress that you saw is about about a year of progress, a little over a year.
It's amazing. Dylan wants to know if you have a repository for all your experiments.
A repository,
like a library of learnings and what you do.
Yeah, so we don't have a library of learnings. That is something that we've been thinking about how to do in the best way. Right now, it's mainly just handled like through Google Docs and stuff like that. That's like number 25 on our list of major things we're trying to solve for.
Did I ask that right, Dylan? Or were you more interested in the components? Yes, cool. Anyone else?
I think Tom had a question. Or wait, maybe Tom was being asked something.
Yeah, Tom. Yeah, Tom was being asked about a something Guido shared, I think. No, something Phone shared for Guido. Go ahead, Ben.
I had a question about those offline experiments and the engagement the testing team has with those other channel departments. With if it's brand or marketing or service, what's the engagement there and the conversations and the adoption for those offline experiments and working together? Curious about the culture there.
Yeah, that's a good question. So we have a, like I mentioned before, we do have a very metrics-driven culture. So even without us being involved, when those teams make changes, so I could actually give you an example of a recent one that I was just working through. We have a offshore team that works, I believe, in the Philippines. And part of what our operation teams does is think about how we can best split work between the sort of US-based team and the offshore team. And so sometimes they might do quote unquote experiments where they're shifting some types of work to the offshore team or taking some types of work back. And usually they have to report on the impacts of this on metrics like, does it affect operational efficiency? Does it affect, have some measure of relationships with our carriers and with our shippers? They're doing all of that stuff on their own already. The problem is they just don't have a good way of automating it. So it ends up taking a lot of time. So in most cases for the offline stuff specifically, when we've gone to people and said, hey, we can take this thing that you're doing and we can generalize it and we can make it totally automated and give you like a surface to do analysis and metrics computation and slice and dice, like they're ecstatic, like they love it.
That's amazing. So my experience in the offline world, the biggest challenge that you have when you're running an experiment that, where you can't control the component parts is sort of the buy-in and the compliance. So for example, if it's a call center based, or if it's in the, physical world and it requires people to follow the process that you've given them, as an example, call center, they might select the reason for calls, whatever's the top ticked thing, instead of following what you need so that you have your data. So, how do you all overcome those challenges with your drivers, with, whatever?
Yeah. So we are a platform team. So we're totally agnostic to the solutions that people come up with. And what we try to do is go to the teams and say, hey guys, you are the team that manages this, right? Operations team, this is your area. Like, you guys have the ball in your court. You tell us what are the things that you struggle measuring with, and we will make the stuff that helps you do that better. And that's what gets them really excited. Because, in the past, like at other teams I've been on when I was at Subway, one of the approaches I think didn't work very well that we took was we would go to some of the offline teams and say, hey, we have some really great ideas about what you can be doing to sort of improve your workflow and potentially improve your product and this type of stuff. And they said, we don't care what you think. we have our own goals that if I don't meet, I'm going to be fired. So I don't really care what you have to say, because I've already decided what I think I need to do to not be fired at my business. And that's the thing I'm going to do.
So
and
you flipped the script now. You've gone to them and said, what do you need?
Exactly. I go to them and I say, tell me what you need and what you struggle measuring. And that's sort of why I mentioned measurement before, because measurement is the universal problem, where
Right.
even if that team who says like, all right, I think I'm going to be fired, so I'm going to do X, Y, Z, in the offline world, it's really hard to prove to your manager that that thing you did is actually having the result that you think it does, if you don't have a very data-driven scientific way of measuring it. So I go in totally agnostic and just say, tell me what you're doing, and we'll figure out how to measurement. And that gets them onto the experimentation tool. And now they're thinking, and those type of suggestions become radically easier when the process itself is simple.
That's brilliant. Any final questions before we let Chad go? We don't care what you think is such a common response. Do you have any challenges justifying the budget for your experimentation or data platform team?
I personally do not. In fact, most teams want us to have more budget. And again, the reason, I think a big reason for that is if some team comes to us and says, hey, we have this big problem in experimentation, and it's literally costing us 2 weeks of engineering time every single quarter, and we go, we can fix that. And we can not only can we fix that, we'll make that take a second. They're like, you guys have just improved the quality of my life so much. Please, if giving you more people is going to improve the quality of my life more, take more people. Again, like, and I say this from experience because I sort of went through what you're going through at Subway. That's not often the case with some CRO teams, because what you're saying is, I'm going to make the business more money, but making the business more money can often look really great for you. And then potentially you can, like, share the results with that team. But it's mainly like, hey, look, the CRO team made an investment and we made $5 million. And this other team just kind of along for the ride, and they had to give us the resources and their time and bandwidth while also working on all their other projects. So it's a very different conversation. I really try to see ourselves as agnostic enablers versus like coming up with any ideas.
I love the focus on improving the basically the ease of not your customers interacting with your website or your apps or your company, but the ease with which people can do their jobs and make better decisions with data. So cycle times and all that stuff is fascinating to me, and using experimentation to do it is even better.
Yeah, exactly.
I want to add, because I want to ask one more question that Edgar is asking. Do you support optimization through bandit algorithms? And I'm curious what tech stack is used for dev.
Yeah, so we use TypeScript. Primarily, we use TypeScript and React, and like GraphQL and stuff like that. In terms of optimization through bandits, not right now, not so far. I think eventually we'll get to bandits. My like, you know, brilliant pie in the sky view of the world. My sort of fundamental philosophy is the ideal view of the world is when you have a system that can self-optimize in many different ways across the business. For Convoy, the sort of vectors that really need self-optimization is the time it takes to run experiments. We have experiments that take 8 weeks because we have very small data. And so if you realize after the experiment is over that there's a bug, you actually can't afford to go back and fix that bug and restart the experiment, because now you've just run your experiment for 4 months and you still don't have a result, and it may not be positive. So there are really great ways where you can impact the power of an experiment. But you need to have a lot of data about previous experiments in order to be able to do that. And you need to put machine learning basically on top of your experimentation platform. So my perspective is the first order of business to get to that amazing future is to gather as much data as we possibly can in the form of a ton of different metrics, a ton of different experiments across like every single change that goes out ideally should have its own experiment, whether it's offline or not. And bandit optimization is sort of like a part of that long-term.
So you're using in the pie in the sky vision of the future is using bandits not to optimize customer experiences, but again, to optimize your experimentation process to run tests faster, get results faster, increase the power of your individual experiments without needing more bodies or eyeballs to do so.
Right, exactly. And if making bandits super easy is part of that, and it would help us get more data, which it would, and if teams have that use case, we would totally be in support of it. But you know, the big dream is because once you do that, then your experimentation platform actually becomes a revenue generation engine, right? You are actually making the company money through your tools directly and not indirectly, and that makes everybody's conversation much easier.
Awesome. Thank you so much. I point out Matt's point that this is like giving half dose of the planned vaccine dose in your experiment to, you know, speed things up. But thank you all so very much. I hope we will have one more conversation in December, but if not, I hope everybody has lovely holidays and a happy new year. And I'm really looking forward to talking to you in January. So bye all. Have a great weekend. Thanks again, Chad.
Thank you.